Hello everyone. In this presentation, we're going to talk about a new data structure about graph. So first, we're going to talk about introduction of graph. All right. So we'll learn few terminology regarding graph. Then we are going to talk about few algorithms that is based on graph. First, let's see what is a graph. So a graph is a data structure. In a graph is a in graph. Uh, is a set of vertex, also known as node. Okay, so V represents set of vertex or node and a set of edges E. So E represents set of edges. Set of edges means you can see that a set of edges means a pair of two node U and V. Okay, both of these nodes U and V are going to be member of the vertex, a member of the set of vertex V. So let's see an example. So a set of vertex in this graph, you can see that we have set of vertex or node like that. So in this graph, we have set of vertex V as we have A, B, C, D, E, F, and G. Okay. So in this graph, we have this node. Now set of edges means a pair of node. So edge actually represents a connection between two nodes. All right. So a edge means it's a pair of two node. Okay. Both of the node is going to be member of this set of vertex or this set of nodes. Okay. For example, here in this graph, you can see that we have couple of edges. One edge means one edge is going to connect two node. All right. So in this graph, you can see that A and B is connected with an edge. All right. So in this graph, we have a set of edges. So the set of edges, if we represent, we are going to represent a set of edges like a pair of node. For example, here we have edges AB. We have another edge that connects B and D. Another AD. So DE, EF, EG, and DC. So we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 edges. So a graph is a set of vertex or node and a set of edges. So set of vertex, they are actually object in this data structure. But what does this edge represent? Edge represent a connection between two object or two nodes. All right. So we can have different type of graphs. How different type of graphs are going to look like, and how we are going to make the categories between different type of graphs. So what are the graph characteristics that we might care about? So we can have a undirected graph, okay, or we can have a directed graph. So one categorization can look like we can have a undirected graph and we can have a directed graph. So another category can be based on the weight of each edge. Okay, so we can have weighted graph or we can have unweighted graph. So let's see how they are going to look like. So an undirected graph means when we're talking about edge, the edges do not have any direction. Okay, so for example, in this graph, you can see that A and B is connected with an edge AB. Okay, now I'm saying that A and B has an edge. Okay, now this edge is actually same as BA. All right, so as there is no direction, I mean AB is same as BA. Okay, they are actually same. There is no difference between AB pair or BA pair. All right, so in an undirected graph, edges do not have any direction. A and B is connected means B and A is also connected. Okay, so here you can see that A and D is connected means D and A is also connected. All right, but a directed graph means in a directed graph the edge is going to have a direction, looks like an arrow. So in the direction means actually the connection have a direction. So for example, in this graph, you can see that the edge looks like an arrow, means actually B is connected with A, but A is not connected with B. All right. So here the connection means the connection is from B to A. So if we represent the edge actually looks like this BA. So in a directed graph, the direction, I mean each of the edge has a direction, okay? And the direction is very important because here BA is not actually same as AB, okay? So in this graph, actually you can see that we do not have AB, okay? For example, here we have a connection from C to D and both D to C. So if they have a connection in both direction, we also have to represent them as a different edge, okay? So here we have both DC and CD, but these two edges are different edge, okay? It says that B is connected with A, all right, but A is not connected with B. So in a directed graph, actually, there is possible that having a edge with the same node, okay, also known as self edge. You can see that A is connected with A, okay. So means there is an edge that connects the same node itself. So it will look like this. Okay, so in an undirected graph, actually self edge, actually we do not represent any this type of connection using self edge, but in a directed graph, based on the application, we might have a self edge, means a edge that connects the node itself, okay. So and here you can see that C and D is connected, and D is also connected with C, and C is also connected with D. All right, so D is connected with E, E is connected with F, E is connected with G. All right. So weighted graph means each edge can have an associated weight. All right. So here you can see that we are saying that A and B is connected. All right. But the associated width of edge, this edge is 8. Now A is connected with D, but associated weight with this edge is 7. Okay. It means that edges have an associated weight. This is known as weighted graph. Now, unweighted graph is actually like this one. This one, we can say that this is an undirected and unweighted graph. All right. So unweighted graph means actually all the edges have same weight. Okay. So edges are not different based on their weight. All the edges have same weight. All right. So this is an example of a directed and weighted graph. Okay, so you can see that edges have an edges has a direction, and also each edge is associated with an weight. Okay, so here B is connected with A, but associated weight of this edge is 8. All right, so D is connected with A, and associated weight of this edge is 7. All right, now you might think that actually where we're going to need different type of graph. All right, so let's see a couple of example actually where we're going to need graph. So so these are some example of graph, means where we can represent the data set, represent the information using graph. Okay, and what type of graph we are going to use. Let's say we want to represent a friendship network, okay, or friendship graph in a social network. Now, what does the social networking means, and what type of information we want to represent in a social network? All right, and if we think about a social network, what is a social network? So social network, the most common one, if we think about Facebook, okay. The basic information of Facebook, if we want to organize as a data structure, we can think about a Facebook or a social network is a collection of user, okay, collection of people, Okay. All right. So let's see, we have collection of people in a social network. Now, as this is known as a network, means what does actually these people are going to do? These people are going to be connected with each other. Okay, so they are going to share information with each other, and first, actually, before they share information with each other and everything, they need a connection. All right, so in Facebook, the connection known as a friendship. Okay, so one person can be friend with another person. All right, so let's represent each of the user as a node. Okay, now we're going to have a edge if one node is a friend with another node. All right, say for example, this is a small social network only with 5 people. Okay, 5 user. So let's see, A is friend with B and A is friend with C. All right, and D is a people, D is friend with E. All right, and E is friend with A. All right, now it means that if 2 people are friend with each other, we're going to represent them as an edge. Okay, so now you can see that we are representing the whole friendship graph in a social network using a graph. Okay, so using graph data structure. So in this graph, we can say that we have a set of vertex A, B, C, D, and E. And the friendship itself, we can represent the friendship using edge. Okay, a friendship means a friendship happens between 2 persons. All right, a friendship means it's an edge, means a pair of node. All right, so in this graph we can represent as a friendship as a set of edges. So here you can see that we are having edges A, B, A, C, all right, D, E, and A, E. All right, so you are seeing a example of graph where actually we can use a graph. Okay, so whenever we have actually a set of object and objects can interact with each other, all right, we can represent them as a graph. So here is an example of social network. Okay, so in a social network we can represent the set of node, set of person, and their interaction between each other as a graph. All right, now let's think about that what type of graph we are going to use to represent a friendship graph. Let's say we're just here focusing on the friendship. Okay, means who is friend with who. All right, so in your social network we can have millions of people, but one friend or one person is going to may have only like 1,000 friend at best. Okay, maybe 1,000 friend, or some people might have only 500 or 100 of friends. Okay, now how do we represent this friendship graph? So if we think about the representation, like the relation of age, okay, so if A is friend with B, means B is also friend with A. Okay, so here you can see that for this age we don't need any direction. All right, so we can represent this friendship information, friendship graph in a social network using undirected graph. Okay, so it means that if A is a friend of B, also means that B is friend of A. All right, let's say we're talking about another social network, and we're talking about a following relationship, for example, like Twitter. Okay, so in Twitter, A follows B. Okay, so if A follows B, that doesn't mean that B also follows A. Okay, so here actually we are talking about a following relationship, means who follows who. Okay, so there are a couple of celebrity, we can say that there are a couple of celebrity, like say just giving a name E. So E can have actually a lot of followers. Okay, all right, but E might not follow anyone, so he might follow some other celebrity. Okay, he might follow only 1 person or 2 person, but if he himself is a celebrity, he can be followed by a lot of people. All right, so following relationship, if we want to represent a following relationship in social network, we can see like we need a direction, who follows who. All right. So the most appropriate type of graph, we might want to use a directed graph. Okay. A follows B doesn't mean that B follows A. All right. So the most appropriate graph is going to be a directed graph. Okay.